This lesson will focus on solving one-step inequalities. An inequality is different from an equation because an equation just has the equal sign. So like if you look at the first graph on the left, on the top, it says x is equal to 2. That is the solution to an equation. So the solution is just at 2, so it's marked. Then you see the graphs using the inequality symbols: greater than, less than, greater than or equal to, or less than or equal to. When you have a greater than or a less than symbol, the circle that you put on top of the number that's in your inequality solution is open, because that is not part of the solution. If I were to put, say for the example, x is greater than 2, if I were to put a 2 on the place of the x, so I said 2 is greater than 2, that doesn't make sense, because if you have $2 and I have $2, we both equally have $2. So it would not be part of the solution because 2 is not greater than 2. Same thing with less than 2. So those circles are open, and then the arrow is pointing in the direction of which the numbers are either greater than or less than. The only difference between those graphs and the ones on the bottom are the ones on the bottom row have the or equal to part. So because the or equal to part is there, the circle is filled in because it is part of the solution. So I could say for x is greater than or equal to 2, I could put a 2 in for x and say 2 is greater than or equal to 2. So we use the same process to solve inequalities that we use to solve equations. So if I had this simple inequality, x plus 2 is greater than 7, my goal is still the same, to isolate the variable. So I start by getting rid of what is on the same side of the inequality symbol, okay, which is the 2. So to get rid of plus 2, I again still have to do the opposite, which is minus 2. So I have to subtract 2 from both sides. So I have 2 minus 2 gives me 0. They cancel out. I'm left with x. I have my inequality symbol greater than, and then I have 7 minus 2 on that side. So I get my solution of x is greater than 5. This slide has exactly the same work, except you can see that this, just like an equation, can be justified. The first and only step that we did was to subtract 2 from both sides. Since we did it to both sides of the inequality symbol, then it is still a property of equality. So our justification for subtracting 2 from both sides is the subtraction property of equality, and we did it to isolate the variable. The x is greater than 5 is our solution, and then I also have showed you the graph of the solution. The circle is at the 5. This circle is not filled in because it's just greater than, and then because x is greater than 5, the arrow is pointing towards the right. If you take a look at this is something that's really important to remember with inequalities that is different than with the equations. It says, if you multiply or divide by a negative number, you must flip the comparison symbol. So if you look at the inequality that we were given in the example, it says negative 2x is less than 6. In order to solve this, you'd have to divide both sides by negative 2 because it's the opposite of times negative 2. The two negative 2's on the left would cancel each other out, and then 6 divided by negative 2 is negative 3. However, because we're dividing by a negative, the number on the bottom of the division problem is a negative, we need then to switch the symbol. So our solution is x is greater than negative 3. So let's take a look at this one. I have 2x is less than negative 6. So to solve this, I would divide both sides by 2. They would cancel. I'm left with x, and then negative 6 divided by 2 is negative 3. Now you have to ask yourself, however, what is the number we divided by? The number we divided by is 2. 2 is not negative, so therefore we do not need to flip that inequality symbol, so it stays less than. So our solution is that x is less than negative 3.